Now, student, you have studied about electric charge and type of charges, basic properties of electric charge, charging by contact, charging by induction. Means in induction, two bodies will get charged without touching, while in contact, the charging is being developed by touching. Here, example 1.1, it is a very important example, and you can understand it. How can you charge a metal sphere positively? How can you charge a metal sphere positively without touching it? So here it has been clarified and explained in a very proper manner. One point I want to tell in this figure, that figure, second figure, you see there is a grounding, means the positively charged sphere is being grounded. Grounded means the ground takes the negative charges. That ground takes the negative charges, and only only positive charge will remain. Only positive charge will remain, and after removing negative rod, a metallic sphere developed positively. You see in figure A, metallic sphere is uncharged, while in figure E, this metallic sphere is positively charged. So in this figure 1.5, it has been explained that how an uncharged body is being charged. So go through the example, and note down. Now next one is basic properties of electric charge, that I have explained many times through my audio lecture and also by my video lecture. So you must note down the important points, like the points which are in italic, that total charge of isolated system is always conserved. Now quantization of charge. Quantization of charge, electric charge is always integral multiple of electronic charge. Electronic charge is small e. So here clearly it has been mentioned. Okay, so this is a quantization of charge. Now in example 1.2, it has been explained that how much time is required to get 1 coulomb charge on other body. Actually, students, 1 coulomb is a very big charge. The smallest possible charge, as you know, that 1.6 into 10 raised to power minus 19 coulomb. And here it has been explained that how much time is required to get a total charge of 1 coulomb on the other body when 10 to the power 9 electrons move out from a body to another body every second. मतलब कि हर सेकंड जो है एक बॉडी से दूसरे बॉडी में 10 टू द पावर 9 इलेक्ट्रॉन ट्रांसफ़र हो रहे हैं, तो दूसरी बॉडी में 1 कूलम चार्ज डेवलप होने में कितना समय लगेगा. तो बच्चों, ये बहुत आश्चर्यजनक बात है. इट इज़ वेरी सरप्राइजिंग दैट वी विल नीड अप्रॉक्सीमेटली 200 ईयर्स. मीन्स हमें यहाँ पर एक बॉडी में 1 कूलम चार्ज डेवलप करने में 200 साल लग जाएंगे, जो कि अपने में काफ़ी इंटरेस्टिंग बात यहाँ पर कही गई है और समझाई भी गई है. और ये सेंटेंस यहाँ पे पढ़ने लायक है. इट इज़ ऑल्सो इम्पॉर्टेंट टू नो what is roughly the number of electrons contained in a piece of 1 cubic centimeter of material. 1 cubic centimeter means the volume of material. A cubic piece of copper of side 1 centimeter, मतलब एक कॉपर जिसकी साइड 1 सेंटीमीटर है, it contain about 2.5 into 10 to the power 24 electrons. So example 1.1 and example 1.212 are very, very interesting examples where you must go through that. In 1.1, it has been explained that how a body is being charged, and in 1.2, it is interesting to note that how much time is required to get total charge of 1 coulomb on the other body, and this is about 200 year, which is very surprising. In also example 1.3 is a very example that how much positive and negative charge is there in a cup of water. We always use a cup for taking tea, taking milk, etc., and taking water also. But here it has been explained that a cup of water, that a cup of water, that a cup of water, how many electrons, how many electrons are there? How many electrons are there? Suppose in this glass, there are 2 cups of water. So in that, how much positive and how much negative charges are there? So by that you can calculate. You can calculate from that. Okay. So go through example 1.1, 1.3, 1.3. These are very, very important. Now next is Coulomb law. The previous lectures already I have given much time, so I will not take much time from 1.1 to 1.5. Now 1.6, Coulomb's law. It is a very, very important topic, very, very important topic of this chapter. What is Coulomb law? Now, what is Coulomb? Actually, Coulomb is the name of physicist, French physicist, and in honor of that French physicist, we give the unit of electric charge as Coulomb. So the French physicist Coulomb has been given or propounded a law in the year 1785. It is nothing but it is a quantitative statement of force between 2 point charges. Force between 2 point charges means if a 2 point charges Q1 and Q2 are separated by distance r in vacuum, the magnitude of force between them is given by equal to F is equal to small k mod Q1 Q2 by R square. This is the mathematical statement, and before that in a paragraph in italic the statement of this law has been given. Now by many experiments the small k, the value of small k has been found as 9 into 10 to power 9 Newton meter square per Coulomb square. The unit of charge that result from this choice is called Coulomb. The Coulomb from which. So in SI unit, the value of K is this. As I have told you that this value has been adopted from several experiments. Actually, Coulomb has taken the help of torsion balance. About torsion balance, you have studied in your class 11th. It's actually this statement F is equal to K Q1 Q2 by R square is similar to F is equal to capital G M1 M2 by R square. And you are already familiar with the mathematical statement F is equal to capital G M1 M2 by R square, which is a mathematical form of Newton's law of gravitation. And here, so these two are actually, you see that in that two law, what is similar? That F is inversely proportional to 1 by R square. Now here you see that 1 coulomb, definition of 1 coulomb, that 1 coulomb is a charge that when placed 1 meter apart from another charge of same magnitude in vacuum, then that two charges will experience a force of 9 into 10 to the power minus 9 Newton. Means if two charges, 1 coulomb each, are kept 1 meter apart in vacuum, then they will experience 9 into 10 to power 9 Newton force. Or here F is equal to, here now see, F is equal to K Q1 Q2 by R square. Now here the constant K has been replaced by 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught. A new constant. A new constant. According to the value 9 into 10 to the power 9 Newton meter square per coulomb square. You see the value of K is about 9 into 10 to the power 9 Newton meter square per coulomb square. So that K has been given as 1 by 4 pi epsilon naught, where epsilon naught is called permittivity of free space or vacuum, and the value of epsilon naught in SI unit is 8.854 into 10 to the power minus 12 coulomb square per Newton per meter square. Now please students note that here two charges are kept in vacuum, therefore the constant K has been replaced by 1 by 4 pi epsilon naught. It is not necessary that the medium between charges is always vacuum. Some other medium may also be present. Without a vacuum. बिना वैक्यूम के कोई दूसरा मीडियम भी हो सकता है. कि दो चार्ज के बीच जो वैक्यूम ना हो के कोई दूसरा मीडियम हो, तब क्या होगा? ऐसी स्थिति में आप क्या करोगे बच्चों? यहाँ पर है 1 by 4 pi epsilon naught है, वहाँ पर आप लिख दोगे 1 by 4 pi epsilon. Means if some other medium is there, then simply you will write 1 by 4 pi epsilon. जहाँ epsilon बराबर क्या होता है? epsilon को हम कहते हैं permittivity of the medium. या इसको आप ये भी लिख सकते हो 1 by 4 pi epsilon naught कैपिटल के, epsilon naught into कैपिटल के, जहाँ epsilon बराबर epsilon naught into कैपिटल के. बच्चों ध्यान दो, यहाँ पर जो k है, यहाँ पर आप देखो 1.1 में तो जो k है वो है स्मॉल k है, वो कैपिटल k नहीं है. तो लेकिन वहाँ पर अगर दो चार्ज के बीच में कोई दूसरा मीडियम है तो हम लिखेंगे 1 by 4 pi epsilon naught कैपिटल k. वैक्यूम के लिए कैपिटल की वैल्यू 1 के बराबर या 1 के इक्वल होती है. तो ये हमने आपको कूलम्ब लॉ के बारे में बताया. इट इज़ ए क्वांटिटेटिव स्टेटमेंट ऑफ फोर्स बिटवीन टू चार्जेस. और आप जैसा कि जानते हो बच्चों, दो चार्ज या तो एक दूसरे को अट्रैक्ट करते हैं या रिपेल करते हैं. टू चार्जेस अट्रैक्ट ईच अदर और रिपेल ईच अदर. इसका मतलब इट मीन्स दिस फोर्स इज रिपल्सिव एज वेल एज अट्रैक्टिव, and the force between these 2 point charges is called electrostatic force. तो इस तरह से आपको हमने कूलम्ब लॉ के बारे में बताया. अब यहाँ पे वास्तव में बच्चों क्या किया गया है, इस डायग्राम में कूलम्ब लॉ को वेक्टर फॉर्म में लिया गया है ना. अब वेक्टर फॉर्म में क्यों लिया गया है? क्योंकि देखो फोर्स इज ए वेक्टर क्वांटिटी और इन कूलम्ब लॉ स्टेट that force between 2 point charges give statement about force between 2 point charges, and force is a vector quantity, so Coulomb law can be expressed in vector form. इसको हम वेक्टर फॉर्म में भी दिखा सकते हैं. आप यहाँ पर आप देखो बच्चों F12 F21 का अर्थ है फोर्स अप्लाइड ऑन सेकेंड बाई 1, और R21 का अर्थ है, फिगर में अगर ध्यान से देखो तो वो है यूनिट वेक्टर पॉइंटिंग फ्रॉम चार्ज Q1 टू चार्ज Q2. Q1 Q2 इज ग्रेटर देन जीरो. कब होगा? जब Q1 Q2 दोनों या तो पॉजिटिव हो या नेगेटिव हो. व्हेन Q1 into Q2 विल बी ग्रेटर देन जीरो व्हेन आइदर टू चार्जेस आर पॉजिटिव और टू चार्जेस आर attractive, and vice versa. So in figure 1.6b, in 1.6b there are two figures. In one figure, there is a repulsion between 2 point charges. In second figure, there is a attraction between 2 point charges shown by blue arrow. Shown by blue arrow. Now, one important point is that here F21 and F12, both forces are same in magnitude. Both forces are same in magnitude but opposite in direction. But opposite in direction. Now, as you know that there is a law which you have studied in your previous classes, that action and reaction, every action has equal and opposite reaction, which is Newton's third law. Means there are two forces which are equal in magnitude but opposite in direction. So here also F21 and F12 are equal in magnitude but opposite in direction. Therefore, Coulomb law agrees with the Newton's third law of motion. So Coulomb law attracts Newton's third law of motion. Now actually two things are there. Coulomb law and Newton's law of gravitation. Both have inverse square nature. But Coulomb law is attractive as well as repulsive, but gravitational force between two masses is always attractive. So this is all about Coulomb law. So dear student, I hope this topic will be clear to all of you. If any query, any question, you can ask. Now the homework is exercise 1.1 and 1.2. Exercise 1.1 and 1.2 question you can solve. 1.1, in 1.1 simply there is a formula you must apply of Coulomb law. Formula of Coulomb law you must apply. That is exercise 1.1. What is the force between two small charge sphere having charge of this and this placed 30 centimeter apart in vacuum? And don't forget to convert centimeter into meter. So just by applying F equal to 1 by 4 pi epsilon naught Q1 Q2 by R square, you can solve this question 1.1. Formula based question. Similarly, 1.2 also, there is a formula based question. Here the distance has been calculated. Distance is being calculated. And force on second sphere due to first. And the B part answer is already given in the question. Student, it is important to note that B part answer is already given because both charge experience the force 0.2 Newton. Whether this force is attractive or repulsive depending on the nature of charges. So 1.1 and 1.2 you solve. Thank you.